Mhm.
Record.
Yeah. So today we are going to do probability. Okay, probability is a very important type. Like at least one question is asked on probability every year. So probability is not very different from permutation combination. Okay, so we have some events which are our desired outcomes. Okay, for example, suppose I toss a coin and I want outcome to be head, then my desired outcome is head. Okay, so then probability of getting head, okay, when coin is tossed, is head is one of the outcome. Okay, and total number of outcomes are I can get head or I can get tail. So probability is half. It's as simple as this. Is there anybody who is hearing probability for first time? Or you know at least basics of probability? So I assume everybody know basics of probability. Okay? Huh? Okay? Because this is AMC 10, 12 class, I assume you know basics of probability. And does anybody wants me to do start from very basic or I should do good problems? Huh? Please respond.
Good problems.
Good problems. Okay. So, okay. So here, very first problem I've chosen this because usually students do mistake here in counting, they do over counting. So how to avoid over counting, that I'm going to do today. Okay. From a regular octagon, a triangle is formed by connecting three randomly chosen vertices of the octagon. So vertices may be 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, what is probability that at least one of the sides of triangle is also side of the octagon? Okay. Now here what we can do is, what are my desired outcomes? What are possible desired outcomes? That at least one of the side of the triangle is side of the okay. So I will start with one side of the octagon. Okay, I should have better labeled it A, B, C, D, E, F. I think. Okay, so let me label it A, B, C, D, E, F, G, H. Okay, and let us count triangles with side AB. Obviously, if I take AB as my side, my third vertex can be taken as third vertex can be taken as either C or D or E or F, okay, or G or H, correct? Huh? Okay, third vertex can be taken anything. Now here, but see, if I take this triangle ABC, ABD, there is no problem in all other triangles except ABH, because ABC and ABH have two sides of the triangle overlapping with the sides of the polygon, correct? Okay, so these two triangles, triangle ABC and triangle ABH, maybe they can be listed in account of AB as well as BC. Okay, AB as well as BC, also AB as well as AH. So they can be counted twice. So in order to avoid over counting, what I will do is I will take AB as the first side, okay, or the you can say leftmost side, okay. when I'm taking anti-clockwise direction, it is leftmost side. Okay. So if I take this as leftmost side, I will say that every triangle I will count in account of leftmost side. Then triangle ABC will be counted in account of AB and not BC, and ABH will be counted in account of AH and not AB. Correct? Followed? So every triangle will be counted in account of only one base. Followed? Huh? So you have to decide your own criteria so that you will not do overcount. Is this clear to everybody? Huh? Any doubt, anybody? Therefore, what we can do is, therefore, now I will not consider vertex H and I will consider only 5 vertices, correct? So there are how many possibilities for AB? For AB as a base, there are 5 triangles, correct? And totally we have 8 sides. So desired outcomes are how many? What will be my desired outcomes? Desired outcomes will be equal to 8 into 5. And what are total outcomes? That will be simply 8 choose 3. Out of 8, I have to select 3, which is nothing but 8 into 7 into 6 upon 3 factorial, but 3 factorial is nothing but 6, so that is 8 into 7. Therefore, required probability will be 8 into 5 upon 8 into 7, that is nothing but the correct answer. Any doubt?
Ma'am, I have a doubt.
Okay. Now, many times probability you can calculate, but it is geometry really helps. So let us see how geometry. Let us see how geometry. I'm sorry. And to with condition that arrives first will not wait for another for more than 15 minutes. Okay. What is the probability? What is the that what is probability that will meet on this particular day? So for that, great help. What I'll do is I'll consider the friend one. Second friend. Okay? Is my voice clear? Is my voice
I
cracking?
think you're lagging.
No, ma'am.
I cannot hear anything.
Okay. Can you hear anything? Can you hear it clearly? Is it better now?
Yeah.
Yes, ma'am.
Thank you. See, so first friend will plot along x-axis and second friend will plot along y-axis. Okay, and what we want is, we want whoever arrives first will not wait for another more than 15 minutes. Okay, so when they will meet provided x minus 1. This difference is less than 50, correct? Less than or equal to 50. Then they will meet, correct? Follow? So now when I know that this diagonal is nothing but this is line x is equal to y. So x minus y is 15 would be this much area. Sorry. Will be this much area. Okay. That will be this area, the dotted area. Correct? Okay. Where this is 15 minutes and this is 15 minutes. And this total is 1 hour. Okay. And this length is, this time gap is 1 hour. That means this is 1/4 of it. So my total area, if I consider as 1, okay, followed, okay. See, what is your probability? Probability is total number of desired outcome upon total outcome. So total outcome, if I considered as 1, if you consider total outcome as 1, because I need to divide by this, okay, then this will be what? This will be 1/4 of total, correct? Followed? And this remaining part will be 3/4 of total, correct? Similarly, this is 3/4 of total, correct? Can you see that? So my desired outcome will cover what area? It will cover the shaded area, which is 1 minus 2 triangles of size 3 by 4, 3 by 4, right? So if I club these two triangles, they will form a square of size 3 by 4. So its area will be 3 by 4 whole square, correct? Okay, which is nothing but 1 minus 9 by 6. Sorry, my bad, because I'm taking area of the square, I need not multiply by 2. So 9 by 16, which is 7 by 16. Remember that probability can never exceed 1. So I immediately came to know my mistake, what mistake I was doing. Okay, is this clear to everybody? Any doubt, anybody? Huh? So
Ma'am, I
7 by
have one doubt.
16. Bolo beta.
Ma'am, you took 15 minutes as 1 by 4 because 15 is 1/4 part of 60, right? Hello?
Yes.
Okay.
Part of this, we are taking 1. Huh? That
Okay.
clear?
I-
Any doubt, anybody?
Ma'am, I had a question in the previous one, but you did not, like you got disconnected.
sorry for internet disturbances because today I am at Narayana Center. Some problem is there. Extremely sorry about that. Yeah, somebody want me to explain this? Somebody want me to
I had a
explain?
question in part 1.
Question here, you want me to re-explain this question?
Not the entire question, just how did you figure out the number of total outcomes?
Acha. See, total outcome, I can always take
No,
one.
for the first part.
Okay. First part means?
Ma'am, he's asking for question
Question
1.
1.
Acha, question 1. Okay. See, total outcome will be, see, you need to form the number of triangles. For triangle, I need 3 vertices. I have 8, correct? So out of 8, I need to select 3. That is 8, choose 3. Followed? Okay, beta?
Yes.
Now, let us go to the
Yes,
next.
I have a question too in question 1.
Beta, is it okay if I give them this question and then go back to question 1? Give me 2 minutes. 2 minutes. Just after 2 minutes, I'll get back to you. Yeah. So here, what I have is I have a pair of fair dice. Okay. Yeah, a pair of fair dice. So we have a pair of dice. Pair of dice. Okay. That is 2 dice. And I'm rolling it for n times. What is the least value of n such that probability that the sum of the numbers face up on a roll equals 7 at least once? Okay. So I'm rolling 2 dices. Okay. And what I want is I want the sum of the upper faces, upper face sum should be 7. This is my desired outcome. At least once I should get some 7. And I'm going to roll this for n times. So what should be the smallest n such that at least sum 7, the probability of this is half. Probability of getting sum 7 is half. Understood? Understood the question?
Ma'am, I
Any
think it should
doubt
be
anybody?
greater than half. It should be greater than half because it's never
Greater
exactly
than
half.
Greater than half. Sorry. Yeah, it won't be exactly half. It is greater than half. Is this clear to everybody? Okay. Now, who had doubt in first question?
Yes, I had a doubt. How did you find out that H was not part of the triangle?
Sorry.
How did you find out H was not part of the triangle?
Yeah, beta. See, because if you take triangle ABC, it will be counted in account of AB and BC both. If you take triangle ABH, it will be counted in account of AB and AH both. Correct? Okay. So, in order to avoid overcounting, because I'm overcounting only in these 2 triangles, but if I take ABE, it will be counted in account of only AB. It would have uniformity, I would have simply divided by 2, but that is not the case. Correct? Okay. Therefore, what I will do is, I need to avoid overcounting. So I decide that whenever I get 2 adjacent sides as a side of triangle, I will pick up the leftmost side first. Okay, I will put this triangle in account of leftmost side. So when I have AB and BC, when I have ABC triangle, that should be put in the leftmost side, that is AB, in account of AB and not in account of BC. Understood, beta? Similarly, when I have triangle ABH, its leftmost side is AH, so put it in account of AH and not in account of AB. Then I won't overcount. Understood? How beta? Therefore, I'm not taking H.
Miss, question about what you just said. Hello?
I will count it in some other way also and show. Okay.
No, I understood what you said. But say you take triangle ABD and ABG, then which triangle falls into which account? Do they both-
Then there is no problem. ABD and ABG, it will fall in account of AB only because there is no other side of this. This question will arise only when two sides are there, right?
Okay.
Or you can do one more way. Or second way is, or you count. For each side AB, there are 6 more vertices, correct? So there will be 8 into 6, that is 56 triangles, correct? Okay. But
Ma'am, 48.
48.
8, slip off, 40, yeah, or 8 into 6 triangles, okay. But 8 triangles out of it will be counted twice, correct? Okay, 8 triangles will be counted twice. At each vertex you will have, if you take 2 adjacent sides, okay, at each vertex you will get 1 triangle which will be counted twice because it will be counted in account of AB as well as BC, like that. So therefore the desired outcomes will be 8 into 6 minus 8, that is 8 into 5. Am I getting the same answer, beta? Okay, is this clear enough? Please respond. Okay. So
Yes,
let
ma'am.
us go. Let us go to the yeah.
This one 4.
Yes, very good, very good. Who is that?
Ma'am, me, Adit.
Adish. Okay. Now, and how many of you have given IOQM?
Ma'am, I have.
Oh, wonderful. I am training students for IOQM as well. I'm not IOQM, I have trained. RMO, INMO, IMO, I'm specialized in training that area rather than this lower level. So those who are interested can contact me, whatever help you want. Okay. Okay. So I hope you have my contact. Okay. Now, a pair of fair dice, okay, rolled n times. What is least value of n such that probability that sum of the numbers face up on the roll equals 7 at least once is at least 7 is at least once is greater than half. Okay. So now suppose I roll a pair of dice. Okay, suppose I roll a pair of dice and suppose I get a number x here. My x takes what values? 1, 2, 3 till 6, correct? What that means 1 is less than equal to x is less than equal to 6. What can I say about 7 minus x? When x is 6, 7 minus x will take value 1. And when x is 1, this will take value 6. Correct? So I can always get, okay, this. Followed? There's some at 7 in any throw. That is possible. But how it is possible? Suppose I get x here, then I should exactly get 7 minus x here. Correct? So probability of getting some 7 is what? There is only one way I can get the sum 7. Provided x is here, then I want 7 minus x. For example, if I get 1 in first die, then I need 6 in second die. If I get 2 in first die, I need 5 in second die. If I get 3 in first die, then 4 in second die, like that. So this probability is 1 by 7. Correct? Is that clear? Any doubt, anybody? Huh? Followed. So probability of getting 7 in one go, in one throw. Probability of getting sum is equal to 7 in one roll, okay, is 1 by 7. Is this much clear to everybody? Any doubt anybody regarding this? Wonderful. Now, therefore, probability of not getting sum 7 is how much?
I have one doubt.
Yes.
Shouldn't be some 7 in one roll be 1 in 6 because there's 6 ways of getting
Sorry.
a 7.
1 by 6, not 1 by 7. Sorry, slip of that. Sorry, my bad. Huh? 1 by 6. Yeah. So it will be 5 by 6. Okay. Is this clear? Huh? Okay. Follow. So not getting some 7. Sorry, slip of that. So will be 5 by 6. This much is clear to everybody? Now, so if I take n such rules, then probability of getting at least one, okay. First, I'll find probability of getting none, and then probability of getting at least one is complement of none. Okay, so probability of not getting sum 7 in n rolls is how much? That will be 5 by 6 raised to n. So probability of getting at least one sum 7 in n rolls, okay, will be equal to 1 minus 5 by 6 raised to n, which has to be greater than half, correct? So that means what? That implies that 1 minus half, which is equal to half, should be greater than 5 by 6 raised to n. So I just need to calculate n such that this works.
Question: how is sum of 7 in one roll 1 by 6? Shouldn't it be 1 by 6 times 1 by 6? Because that's the probability of getting like x in one roll and then getting 7 minus x in the other roll.
Beta, x can take any value.
Right.
For probability of x is 1. Or you can take it this way. Okay. See, if first you get 1, then in second you will get 6. First you get 2, then second you will get 5. Like that.
Okay,
Understood?
got it. Yeah.
Got it? Okay. Or 4, 3, then 5, 2, and 6, 1. Okay. So totally there are 6 favorable combinations out of 6 square. Okay. Take it this way then. Understood, beta? Now, so what is smallest such n? Okay, so if you calculate, you will get n is you will get 5 by 6 raised to 4 is less than half, is less than 5 by 6 cube. Okay, because 5 by 6 is less than 1, its higher power will go on decreasing, correct? As 5 by 6 is less than 1. Okay, followed. So if n is greater than n, then 5 by 6 raised to n will be greater than 5 by 6 raised to m. Its higher power will go on decreasing because I'm multiplying by a number less than 1. I hope everybody knows this. So smallest such n is equal to 4, or required n is equal to 4. Okay, I'm not going to show you calculation. We'll save time. Is that clear to everybody?
Yes, ma'am.
Very. Now, secondly, you should note that when they are listing, when they are describing the problem, this note I have written, they will never write this. Unless they specify, we have to consider the objects distinct. This is very important because then we will get confused whether objects are distinct or similar, then the probability changes, right? Okay, so unless they have specified, we have to consider objects distinct. Now, each of 20 balls is tossed independently and at random into one of the 5 beans. Let P be the probability that some bean ends up with 3 balls, another with 5 balls, and other 3 with 4 balls each. Let Q be the probability that every bean end up with 4 balls. What is P upon Q? So here we are assuming balls as well as beans are both distinguishable. They are all distinct. Okay? Is this clear to everybody? Now, so I have 5 beans, okay, and what is probability? One of the bean has 3 balls, okay. Second bean has 5 balls and remaining 3 has 4 balls. So number of ways of distributing this would be 20 factorial upon 3 factorial, 5 factorial, 4 factorial, 4 factorial, 4 factorial. Correct? Permutation with repetition. And because I have to select out of 5 beans, I have to select 1 bean for 3 balls. That can be done in 5 ways, and another bean for 5 balls that can be done in 4 ways. This divided by, now this divided by total random distribution, okay, of 20 balls randomly distributing in 5 beans, okay. That is each ball has five possibilities, okay. Each ball has 5 options, so that will be equal
We actually
to
don't need to calculate that.
first ball has 5 options. We actually don't need to calculate that, but I'm still showing that if you have to just count this thing, okay, you should know how to count. So each ball has 5 options, so 5 raised to 20. So my P is this, correct? And what is my Q? Q is a probability that every bean ends up with 4 balls. Okay, so Q will be equal to 20 factorial upon 4 factorial, 4 factorial, 4 factorial, 4 factorial, 4 factorial upon 5 raised to 20. Okay, so P by Q is
I don't understand why we're using 4 factorial. I don't understand why we're using 4
because
factorial.
it's permutation with repetition, beta. Permutation with repetition.
I also don't understand why 20 factorial is used.
Beta, have you not done permutation? Beta, have you not done permutation with repetition? This is the formula for permutation with repetition. Beta, unfortunately, we have very less time. So if you want me to explain the formula for permutation with repetition, you will have to wait for end of the lecture. At the end of the lecture, you can remind me, then I'll explain you. Right now, it's not possible. Beta, is that okay? You will have to assume this formula. Okay? End of the lecture, I can explain. So this divided by this, and then calculation. Is it okay if I skip the calculation? Okay, you will be able to do it. But let me do the questions first. Now, this is also easy question, but if you want, I can quickly do it. Okay. Is it okay if I leave the calculation?
Yes, ma'am.
Yeah. Okay. So we can do more questions. Yeah. Now, Una rolled 6 6-sided dice. Okay. So we have 6 dice and rolled simultaneously. Calculate the product of 6 number obtained. So I will take product of all the outcomes. What is probability that product is divisible by 4? Now, remember that there will be many possibilities that product is divisible by 4. There will be less cases the product is not divisible by 2. So let us count first. Let us first count probability of product is 4 doesn't divide the product. Okay, follow? Huh? So what are possibilities? So case 1, that all outcomes are odd. All the outcomes are odd. Now, what is a possibility that single outcome is odd? Okay, probability of one odd outcome
Ma'am,
is
1 by
what?
2.
1 by 2, because there are exactly three odd numbers, 1, 3, 5. Okay, followed. So it is 3 by 6, which is equal to half. Correct? Okay. So probability of all outcomes are odd will be equal to 1 by 2 raised to 6. Correct? Which is 1 upon 64. Correct? Case 2 will be probability of exactly one outcome is 2 mod 4. Means what? It is divisible by 2 but not by 4.
Ma'am, we
is-
can say odd multiple of 2.
Correct. Divisible by 2 but not by 4. And rest all are odd. Correct? Exactly. 1 is divisible by 2, not by 4. And remember, rest should be all odd. Otherwise, if we have 2 even numbers, again, the product will be divisible by 4. Okay. So how many numbers are there which are 2 mod 4? 2 and 6. Correct? There are 2 numbers which are 2 mod 4. So here probability becomes 2 by 6, which is 1/3. Correct? Okay. Now my 2 mod 4 can be first dice or second dice or third dice. It could be one of the 6 dice. So here probability is 6 into 1/3 into 1 upon remaining will be half only. Correct? Followed. So remaining 5 will give me probability half. Correct? Okay. Understood? So that
Miss, why did it went from power 6 to power 5?
Sorry?
Miss, why did you went from power 6 to power
See
5?
that. Because how many are odd, beta? Only 5 are odd, right? Okay. Why we had 6 here? Because here all 6 were odd. Understood? Huh? Here all 6 were odd. All 6 outcomes were odd. Now here rest 5 are all odd. So rest to 5. Is that clear, beta?
Ma'am, one question.
Yes.
Ma'am, can we also count in a different way, ma'am? Maybe we can, ma'am, because if the first 2 dice out of 4, ma'am, create a product that's divisible by 4, ma'am, the other 4 dice don't count, ma'am. So what we could do is we could calculate the number of ways we get
It's
a product.
2 minutes.
Yes.
Students will get confused. Can you give me 2 minutes?
Yes, sure, ma'am.
Please. Please. Yeah. So here, so total number of probability of 4 doesn't divide the product. Okay, will be 1 by 64 plus 1 by 16, which is nothing but 5 by 64. Correct? Because 16 fours are 64. Therefore, probability that 4 divides the product will be how much? It's a complement of this. So 1 minus the probability of this, which is nothing but 59 upon 64. Understood? That is C. Huh? Any doubt? Anybody?
Ma'am, ma'am, I didn't understand that in case 2, why did you multiply it by half raised to 5?
Half raised to 5. Yes, but see, rest 5 numbers will be odd, beta. Only one number is divisible by 2. Only one number can be either 2 or 6. But see, if I take 2 and then second outcome is 4, or second outcome is 6. Is it allowed? No, I don't want this to be even numbers, because then the product will be divisible by 4. So I want one of the 6 outcomes, one of them, any one of them. Suppose this is 2 or 6, then all these are odd, correct? So what is probability of odd? Each will have probability half, correct? Followed? And this will have probability what? This will have probability 1/3. But this could be my first number or second number or third number or fourth number or fifth number or sixth number. Therefore, I multiply by this 6. Is this clear now?
Yes, ma'am.
Okay. Followed? Now, let me just explain the next question so that people will start trying next question, and then somebody has second method. Okay.
Yes.
I'll just explain this question and then we'll discuss the second, so that we'll save time. A point is chosen at random within a square with coordinate plane whose vertices are 0, 0, 22, 20, 20, 0, 20, 20, 20, 20, and 0, 20, 20. Okay. So let me draw a square. Just a minute. I think I need little more space. Okay. So what I have is, I have this at 0, 0. Sorry, 20, 20, 0. 20, 20, 20, 20, and 0, 20. Okay. Probability that the point is within t units from a lattice point is half. Okay. Now, lattice point is what? XY is called lattice point provided x and y are both integers in this natural number or 0. Okay. So I need not consider this. I can consider any lattice square only. Okay. Because for each lattice square, it will be equal probability. Can you see that? For each lattice square, it will be equal probability. So it will be, what I can do is, I will consider this x comma y. This is x plus 1 comma y. This is x plus 1 comma y plus 1, and x comma y plus 1. These are my four lattice points. So this is my unit square. Okay.
Ma'am, is the answer B, 0.4?
Yes, that's correct. Very good. Well done. Now, so what is probability that point is within d units of a lattice point? So d units, so I will get arcs of d units. Assume they are all equal. My drawing is not that good. So these are all arcs of d units. Okay. So probability of this is half. Okay. So probability that their point is within a point, suppose I call it point P. So point P is, okay, I better write it this way. Probability that distance of P from lattice point is less than or equal to d units. Now within d units, so less than or equal to d units, this probability is half. Okay, followed. Then I want to find out value of t. Everybody understood the question? Okay. Everybody understood the question? Everybody understood the question? Any doubt, anybody?
Ma'am, why you draw the arcs?
Yeah, because d units from lattice point means what, beta?
Okay,
It
ma'am.
could be d units in this side, this side, this side, this side, anywhere. Outside also, but For every unit square we can calculate, and for each unit square it's equal probability. Correct? Huh, beta?
Yes, ma'am.
Huh? So it's not required to calculate for such a big square. We can calculate for unit square, and for each unit square it's equal probability. So total probability will get. Huh? Is that
Okay,
clear?
ma'am. Yes, ma'am.
Okay. Now I think you people try this problem. Somebody had something to comment on previous problem.
Ma'am, I had a
think
question.
second method or something. Yeah.
Yes. So, ma'am, for this question, what I wanted to ask, ma'am, the one above, ma'am, the one you were covering before this.
Yeah. Yes.
Yes. So, ma'am, for this, I wanted to ask, ma'am, technically, if we think about it, it's possible that the product for all 6 dices is divisible by 4 if the first 2 create a product that's divisible by 4, right, ma'am?
Yeah, but that is not the only case. Huh? If product of
Ma'am, if the product of any 2 dice is basically divisible by 4, the rest of them multiplied with
2
it.
is divisible by 4.
Yes,
Correct.
ma'am.
Huh.
So, ma'am, that means that if we calculate the number of ways that 2 dice can create a product that is divisible by 4, the rest of them can just
Correct.
give you 6 to the power 4.
Yes, perfect.
So, ma'am, why don't we try it like that, ma'am? Because, ma'am, from that, but I get the wrong answer, ma'am. So I wanted to
You try it now. You try it now. It will be lengthy count.
Yes, ma'am. I didn't get the right answer either.
See, this is case 1. This is just case 1. Case 2 is only one outcome is 4.
Yes, ma'am. Ma'am, we can
And there
consider
will be
that to the
too
first case.
much of overcount. See, here there will be too much of overcount. See, if you take first and second, this product is divisible by 4.
Yes, ma'am.
And rest, you are taking anything, right? So
Yes,
their
ma'am.
product will be also divisible by 4 possibility. So 1, 2 is divisible by 4 and 5, 6 is divisible by 4 will be counted in account of 1, 2 also and 5, 6 also.
Okay, ma'am.
So it's very difficult to count this way unless you use inclusion, exclusion, or you have to be very, very careful while counting. Yes, Krisha, you want to say something?
Yes, miss. Is the answer for the 7th one 0.7?
7th one. I don't remember the answer. I'll have to calculate and check it better. Because usually I don't calculate or anything. And okay, just give me 2 minutes. Beta, just give me. Your doubt is clear, beta?
Yes, ma'am.
Okay, now let us go here. Now, so here, what I need to count is my desirable area. What is the desirable area? Desired area is 4 quarter circles. So that is a single circle. 4 quarter circles, which is a single circle. So 4 into, which is a single circle. So can I directly write down? That is nothing but pi d square, correct? And therefore the probability and total area will be 1. So probability will be pi d square by 1, which is supposed to be half or greater than half.
Miss, how do you find out pi? Where did that come from?
Sorry?
Where
Sorry?
did pi come from? Why did
Beta,
you
what is area of the circle, beta?
Oh, okay.
Area of the circle. Which is
How much
equal
pi r
to
square?
half. Equal to half. Probability is within D is equal to half. Now, therefore, my D square, okay, D square will be equal to 1 upon 2 into pi, okay. Now, pi is something approximately 3.14. This is less than 1 upon 6, correct? And 1 upon 6 is approximately 0.16. Okay, followed? Greater than 0.16, but pi is greater than 1 by 6. So I can say that D should be nearby to 0.4. because we want nearest 10. So this is how I will approximate. Followed? Okay, 100 divided by 6 is 16, 6 are 96, correct. Huh? Is that you people? Huh? Followed?
Ma'am,
Yes.
why did you consider the total area as 1?
Huh, beta. Total area of a square, you always consider 1. It will be easier to count. Always. And this distance is d. Huh? Okay. Huh? Always take, and here especially these are lattice points. So this distance is 1 unit, right? Even this distance is 1 unit. So their total area of square is 1. It has to be a unit square. Huh, beta? Okay. Taking it unit square make the job very easy. Huh? Followed? Huh? Understood? But everybody understood how I approximate this?
Yes.
No. No. Actually, the time is up, but if you want, I can show 1 or 2 good questions. Huh, this is a nice question.
Excuse me, ma'am.
Yes, beta.
I got locked out. I was asking that in the previous question, why did you consider the total area as 1?
Beta, it is a lattice points. No consecutive lattice points will have the gap of 1 unit. So what is side length of the square?
Okay,
1 unit.
got it.
Right?
Got it.
Beta? Now, real numbers x and y are chosen independently and uniformly at random from an interval 0 to 1. Which of the following numbers is closest to probability that x, y, and 1 are sides length of an obtuse triangle? Okay. Now pay attention. What is condition for x, y, and 1 are? See, x and y lie between 0 and 1. Correct? So what is condition that x, y, and 1 forms a triangle? Clearly, 1 will be the possible largest side. So by triangle inequality, sum of 2 smaller sides should be strictly greater than the larger side. Correct? This is first condition.
Excuse me, ma'am.
Yes, beta.
Is it 0.5?
I don't know answer by heart. I've just copied paste this question. I've not tried it. Huh? Frankly speaking, I'm too busy teaching for my IMO and INMO aspirants. Huh? Okay. So I'll just quickly solve it and tell you. Huh? Is that okay? Huh? Okay. Now, usually my lecture starts morning 9, and just before your lecture, I just finished my last lecture. Like I left it early at 4:45 because I wanted 2 minutes break in it.
Yes, ma'am. I'm
So-
also getting 0.5.
Oh, so that must be the correct answer. Okay, let us check. Yeah. Now, second condition is that it should be an obtuse triangle. What is condition for obtuse triangle? That
one angle is greater than 1.
Yeah,
20.
90 degree. But on condition of side should be x square plus y square should be greater than 1. Huh? Everybody know this condition or not? Okay, 2 minutes you assume this. We'll solve this question and I'll prove this condition for you. Huh? Just 2 minutes assume. Okay, so now this is my second condition. Followed. So oh, sorry, less than 1. What I'm doing? This is less than. Yeah. Now, therefore, what is this? This locus looks like what? See, always check what does the graph looks like. This condition we know that x square plus y square is 1 is equation of unit circle. Correct? So x square plus y square is less than 1 is interior of unit circle. With center at 0, 0. Correct? Followed? With center at 0, 0. Correct? And x plus y is greater than 0. What is this? X plus y is greater than 1. X plus y is equal to 1 is a straight line. Correct? This is a straight line. X plus y is equal to 1. So x plus y is greater than 1 is this area. Correct? Followed? Is that clear? Huh?
Shouldn't the
Followed?
line actually be not there? Shouldn't it
No,
pass
no,
through the?
line is not the. Sorry.
Ma'am, that's the
Oh,
equation
sorry,
of x
sorry,
plus y
sorry,
equals
sorry,
0.
sorry, sorry, sorry. X plus y is equal to 0. 1 means actually it will pass through here. Sorry, my bad. X plus y is equal to 1 will pass through here.
Ma'am, I don't fully understand how we derived condition 2.
एक second, huh? We will draw it. Okay. We will do that. Okay. See, okay, obtuse angle.
Excuse me, ma'am. Ma'am,
By
actually,
cosine rule, 2 minutes. Give me 2 minutes. Huh?
no,
2
I'm
minutes.
saying the answer. I'm just asking, is the answer 0.29? I made a mistake in my previous answer.
I really don't know. I will calculate now. But
Okay.
give me 2 minutes. Okay.
Okay, ma'am.
Now here, see, use cosine rule.
Yes, ma'am. I tried that, ma'am, but I got an
Yeah, 2 minutes.
inequality, ma'am.
2 minutes, beta. Allow me to speak.
Yes.
I will. Suppose this side is 1 and this side is x and this side is y. Okay. And this is your obtuse angle. Okay. So 1 square will be equal to what? That will be x square plus y square minus 2xy and cos of this angle A. Correct? Because A is greater than 90 degree, what can you say about this cos A?
Is negative.
Is negative, correct? Okay. So
Cos A
we
is-
will take cases. We'll take cases when A is greater than beta. When A is equal to 90, cos A is equal to 0. So I'll get 1 square is x square plus y square. Followed? Okay. Or let us not do it one. Let us do it in general. Okay. Let us do it in general. So you have in general formula. Let us do it A, B, C. So A square, B square, C square. So cos A is 0. So 2bc cos A. So in this case, you will get A square is equal to B square plus C square, Pythagoras theorem. If A is less than 90, then cos A is positive. So clearly, A square will be less than B square plus C square. Correct? And if A is greater than 90, then cos A is negative. Then this term becomes positive. So A square will be greater than B square plus C square. Is this clear to everybody? Any doubt, anybody?
Yes.
Okay. Now, so what I want is, I am selecting X and Y from this set, correct? 0, 0 to 1, 1, correct? X is over here and Y is over here. So I'm selecting XY on this unit square, correct? And what I want is x square plus y square is less than 1. Okay. And x plus y is greater than 1. So I have this much area, correct? Or not? This is my desirable area, correct? Or not? So what is desirable area? that is a quarter circle minus triangle. Let us label this triangle, suppose APQ. Minus triangle APQ. Understood? So what is area of quarter circle? That is 1/4 minus, sorry, I mean to say slip of tongue, pi/4, because radius is 1, okay? Minus area of quarter circle will be, that will be half into 1 into 1, correct? That is half. So pi is 3.14 upon 4 minus half will be the area of this. That is nothing but 0.7, so 3, so 8.5 minus 0.5. So this is roughly, yeah, 0.285, which is approximately 0.29. Okay, or not? This is desirable area. Now probability will be equal to probability, required probability will be probability for this condition, okay? Probability of given condition will be equal to desirable area upon total area of square. Total area of square is simply 1, okay? So my probability will be 0.2. Yes, correct. It's 0.29. I think somebody has given me correct answer. Okay, is this clear to everybody? Any doubt, anybody?
Ma'am, I'm a little confused about how you chose the desirable area. I'm a little confused with that.
I'll explain. Okay. See, pay attention, huh? Pay attention. See, first of all, everybody understood the condition for obtuse angle triangle?
Yes, ma'am.
That, sorry. Color. Yeah, that the largest side square should be greater than sum of two squares. So x square plus y square should be less than 1. So x second. Huh? Yeah, so this is nothing but interior of this circle beta. Okay, but I want x plus y to be greater than 1 at the same time. So this is my line, x plus y is equal to 1. Right, bacha? Huh?
Yes.
Okay. So my x plus y is greater than 1 is, sorry, is this line. Okay, so I want my x plus y to be greater than 1. So I want area above this line. Beta. I want area above this line, and at the same time I want
within the circle.
Within the circle. Okay, so just shaded area. Huh? Okay, and then it is a area of the sector. Then it's just a calculation part.
Ma'am, and the circle that you've drawn is the interior circle of the unit circle, right?
Not the interior. It's just unit circle only with
Okay.
0, 0.
Okay, ma'am. Yes, got it.
See. Followed? Understood?
Yes, ma'am.
Okay. So anybody has any doubt, or may I stop here? Okay, and I think I want you to help me in helping you. Whatever topics you feel are weak or you want me to cover, please message me on this number. So I'll be able to, my name is Komal Ghadikau. I'll be able to help you. I think many of you have asked for geometry. Okay, so I'm going to take up geometry, but after I finish with probability, because probability is comparatively very economic topic. In less studies, I can guarantee there is at least one question every time. Followed? So I've taken probability. Maybe next turn I will complete probability, and then after that we'll start with geometry and any other topic if you tell me. Okay? Because it should be a tailor-made course. Whatever you want, that I should give prioritize. Otherwise, if you are already good with some topic, then we should not waste time on that topic. Huh? So please text me. Okay? Wish you all the best. Anybody has any doubt on anything? Or may I stop the lecture? Okay. Yes,
I'm
Beta?
a little confused about why x plus y has to be greater than 1.
Okay. See, Beta, in triangle, sum of any two sides is always greater than the third side. Why? Suppose I want to draw a triangle such that A is 10, B is 5, and C is 4, Beta. Okay. So let us try to do this construction. Let us try to take BC as 10, and from B, I will take an arc of 4 units, and here I'll take an arc of 5 units. Then I'm covering 9 units, and there is a gap of 1. Will the arcs meet anytime?
No, okay, I got it.
No.
Yeah.
Even if it is B plus C, even if A is equal to B plus C, then also they will meet on this point, beta. Understood? Therefore, sum of two sides should be always greater than third side. Now, if I know A is the largest side, A is greater than B plus C, then obviously A plus B is greater than C and A plus C is greater than B. Therefore, we take B plus C should be greater than A is a condition for triangle. Understood? Huh?
Yeah.
Followed? That sum of two smaller sides should be greater than the third. Huh? Followed? Is that clear? Huh? Any doubt, anybody?
No.
Okay. So may I stop here?
Yes.
Okay. All the best.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you. Bye.